All right, welcome to the first video of section 2.2. In this section, we are going to look at the properties of a quadratic graph. So we're gonna look at quadratic functions and look at them in some different forms and talk about some of the properties that their graphs have. Now, just a couple reminders, just refreshers for you. So before we even get into this problem, let's just look here at our parent function for quadratic. Okay, remember that our parent is x squared. F of x equals x squared. And what that looks like is it is a parabola that looks like this. Okay, now remember, parabola is the smooth, curve-shaped. And last section, we learned a vocab word. We learned this term called vertex. Okay, remember, vertex is it's either the minimum or maximum point on our graph. It's the highest point or the lowest point on a parabola. It's the point at which our graph switches directions. You know, here we're decreasing. At our lowest point, we now switch and we're coming back up. That's our vertex. Now, you also saw vertex form of a quadratic last time. So vertex form is in this format here. Okay, just like with linear equations, you have slope-intercept form and point-slope form. Well, we have vertex form for quadratics. So remember, when you have a quadratic in vertex form, the values h and k give you the coordinates of your vertex. So h and k give you the coordinates at which your vertex is located. Now here, if we look at our parent function, remember, we could just rewrite this. This is just the same as x minus 0 squared plus 0, right? X squared and this right here, x minus 0 squared plus 0, are the same thing. And you see we get the coordinates of our vertex, 0, 0. That's the origin. So that's our parent function, okay? Now, all parabolas are symmetrical. That's one of the properties of them. What that means is if you drew a line down the center of your parabola that crosses through the vertex, that both halves of your parabola are identical, right? All of the points on one side have an equivalent point that's equal distance from the center line on the other side. We call this the axis of symmetry, okay? This is our axis of symmetry. And the way that we write our axis of symmetry is this is a vertical line. So it's going to be an equation of the vertical line, which remember, vertical lines are constants and they are just x equals whatever x value it crosses through on the x-axis. Okay, so that should help you for this first one where we have to label the vertex and the axis of symmetry. We can get our point from vertex form, and our axis of symmetry is simply going to be the vertical line that crosses through our vertex. Now, this just so happens because the x-coordinate of our vertex is just h, that means that our equation for our axis of symmetry is always going to be x equals h. So whatever this h value is in vertex form, x equals h is the equation for your axis of symmetry. So let's also look at how we graph this equation right here. So there's a lot of things that we just did. Axis of symmetry and vertex you should have heard before, but vertex form and getting this information from vertex form and the axis of symmetry might be new. So you want to make sure you have all this jotted down in your notes, rewind it if you need more. Okay, so let's go ahead and go through this problem. So if we notice from this is our graph, our equation that we're going to graph, and we need to get the vertex and axis of symmetry. So we can already see that this is nice and neat and in vertex form for us already. So what we want to do is go ahead and pull the information that we know from this. So since this is in vertex form, right, -2 is just our a value. Our h value is -3. Remember, it's x minus h. So x minus -3 gives us x plus 3. And then we have h equals 4 plus 4. So these are our constants. So what this tells us is that our vertex is at the point -3, 4, and our axis of symmetry goes through the line x equals -3. So here we've got our axis of symmetry. Here's our vertex, -3 and 4, and our axis of symmetry is the vertical line that goes right through it at x equals -3. Now, what we want to do in order to graph this, we want to go ahead and evaluate some functions for x. So evaluate this function for 2 values of x. So right now we only know the vertex. We don't know how wide this is or how narrow it is. But we're going to use the fact that it's symmetrical to plot this by just evaluating a few points. So let's go ahead and do the next step. So the 2 points we're going to pick are -2 and -1, just because those are right next to our axis of symmetry. And what that tells us, if we go ahead and plug in -2 for x, we get y equals 2. And if we plug in -1, we get y equals -4. Now, what that tells us, so since we know from this right here, we know when x equals -2, y equals 2. So that tells us that this right here is a point on the graph. Now, because this is symmetrical, we know that if we go out the same distance to the left, that we're also going to have a point at the same y value. Okay, so -2 is 1 unit to the right, and that's at y equals 2 is our point. If we go 1 unit to the left, we're going to have another point at y equals 2. And for x equals -1, since we know we have a point at -1 and 1, 2, 3, 4, since this is 2 units to the right, if we go 2 units to the left, we know we're also going to have a point at -4. That's how we use this fact that parabolas are symmetrical. That's how our axis of symmetry helps us plot it. We figure out our vertex, and then we figure out 2 more values, and then we plot the symmetrical values on the other side of our axis of symmetry. So let's go ahead and look what our finished graph looks like. So we plot those points, then get the symmetrical ones, and then we just go ahead and connect it with a smooth curve, and we have our parabola. So that's how we use the vertex and axis of symmetry to graph a parabola when we're in vertex form. So what I want you guys to do right now is I want you to look at problems 1 and 2 and give me the vertex and the axis of symmetry. Obviously, you can't graph it, but in the text box that pops up, go ahead and enter in the vertex and axis of symmetry for 1 and 2. And remember, axis of symmetry should be in the form x equals, and vertex is a point. Go ahead and enter that now.